number 9, and we're looking at theorem 1.6, and we're going to start with part I. If A does not equal 0, then its reciprocal, A reciprocal of A does not equal 0, and the reciprocal of A is equal to A. So basically, if we took A to the negative 1, right, made it 1 over A, and the reciprocal of that is A. So this is similar to what was done in Theorem 1.2, where we looked at A plus X equal to 0, where minus a negative A was looked at equal to A. So we used X equals minus a negative A, and we put A plus minus a negative A, substitute that in for X. And so from there, we had, if we were to substitute in a negative A in there, and then multiply negative all the way across, we get negative A plus A equals 0, and we get 0 equals 0. So if you're not sure, go back and look at Theorem 1.2 again. So instead of A plus X equals 0, we're using the inverse of A times X equals to 1. Since we're looking at the reciprocal is A, so we're going to use times here. And we're saying here X is equal to the reciprocal of A. So we're substituting this in to prove that both sides equal. So if we have here the inverse of A times A to the negative 1, or to the negative 1, reciprocal of the reciprocal. Now if we looked at this as 1 over A and the reciprocal of that, and then apply the reciprocal of 1 over A, we get A. And then if we went ahead and applied the reciprocal of A to the negative 1 power, that's 1 over A times A equal 1. Well, these two cancel out, and we get 1 equals 1. And it holds, both sides equal. So we took the reciprocal of A, substituted in here, and we said that that equals A. So when we do that, then algebraically this should work out. So you don't have to apply the reciprocal. I mean, you don't have to make this 1 over A. I did just to make it visually clearer. And then we see that both sides equal and it holds. Okay, that's the first part. Then the second part, II, that states if A does not equal 0 and B does not equal 0, then A times B the reciprocal of A times B is equal to the reciprocal of A times the reciprocal of B. Again, this is similar to proof in 1.2. So if we have here, if we have A times X equals to 1 again, then we're saying X is equal to the reciprocal of A from axiom M5, M-5. So now we're going to so we already proved this to be true. So now we're saying let AB times X equal to 1. So now instead of just AX equal 1, we're saying A times B equals to 1. And so we're saying let X equal, instead of X equal the reciprocal of A, let X equal to the reciprocal of the product of A times B. Therefore, we can say A times B times, and now we're going to substitute the reciprocal of AB should equal 1. So we're saying that A times B to the negative 1 is reciprocal of A times the reciprocal of B. So therefore, we're making this AB times reciprocal of A times the reciprocal of B. Okay, so go back over this. We're saying A times B times X equal 1. Let reciprocal X equal to the reciprocal of AB, because we want to prove this. We want to prove this part here. So we substitute reciprocal of AB in, and we're saying that A times the reciprocal of A times B is equal to the reciprocal of A times the reciprocal of B. So let's test that. So we change the product of A times B, the reciprocal of that, to reciprocal of A times the reciprocal of B equal to 1. All right, well, let's see if this is true. So through commutative property, we switch A and the reciprocal of A and B. So this is A times the reciprocal of A times B times the reciprocal of B. And so A times its reciprocal, that's A times 1 over A times B times 1 over B. And so A times, that's going to be 1. B times its reciprocal, that's going to be 1. So 1 times 1 is 1. And it holds. Algebraically, it holds. So we have proven that we took A times B of its reciprocal is equal to reciprocal of A times reciprocal of B. We put that in our equation, and it algebraically worked out. So it proves that theorem. And that's our theorem.